Okay, in this video we're going to talk about some tips on when you see a chemical formula, how do you recognize it as being an acid or a base? And I would say this video is very specific to students in my 1212 classes. Depending on where you are in chemistry, your definitions of acids and bases may be broader, and things that you would be expected to recognize as acids and bases might be different. Alright, so in the first semester of general chemistry, we generally taught you to recognize acids when the formula had an H in the front, right? So if we have HCl, H2SO4, HCN, the fact that the formulas start with an H was a good indication that we were dealing with an acid. However, when we start dealing with organic acids, that may not be the case. And a very common class of organic acids are called carboxylic acids. And so acetic acid is an example of that. So let me draw the Lewis structure for acetic acid. And so when we have this grouping of atoms, where we have a carbon double bonded to an oxygen, and then that same carbon is connected to an oxygen, which is connected to a hydrogen, this grouping of atoms that we might call a functional group is acidic. And so all carboxylic acids have this same grouping of atoms. And so the way an organic chemist might write the formula for acetic acid is CH3COOH, right? Because they're sort of writing the formula to describe what the molecule actually looks like, right? We have a CH3 and then a COOH. So anytime you see this in a chemical formula, they're telling you that it's a carboxylic acid, and so we should recognize that as an acid. All right, similarly, in general chemistry, when we talked about bases, the bases that we typically dealt with were salts of hydroxide ions. So NaOH, MgOH2, FeOH3, those would all be recognizable as bases because they contain hydroxide ions. And so when they dissolve in water, they'll produce hydroxides. However, another class of bases that I want you to be on the lookout for are amines. These are basically derivatives of ammonia. So ammonia is NH3, and when you have this lone pair on a nitrogen, that is able to accept protons from acids. And so any organic compounds that you see that have nitrogens in them, they very well may be bases. And so CH3NH2 is another example of an amine and a compound that we would classify as a base. And when I draw its Lewis structure, you can see it looks very much like ammonia, where we've got a nitrogen with 3 bonds, and then it has this lone pair that will be able to accept protons from an acid. All right, so let's look at some examples. So for each one of these compounds, we want to decide, is it an acid, a base, or a salt? And then if it's an acid or a base, we want to determine whether it's strong or weak based on the 7 strong acids and 8 strong bases that we've learned previously. Now, this question can be a little bit more complicated than we're discussing here, because as we're going to learn later on in this chapter, salts themselves can be weakly acidic or weakly basic. But right now, I just want to know, would we classify the compound as an acid, a base, or a salt? And we'll talk about the acidity and basicity of salts later on. So, calcium carbonate. This is an ionic compound. I have no H's in front, I have no hydroxides, and I don't see the COOH functional group that would tell me it's an organic acid, and I don't see the nitrogen attached to an organic molecule that would tell me it was a base, and so this would just be a salt. Right? H2SO4, right? This follows our convention for inorganic acids. I've got the H's in front, and so I recognize this as being an acid. Right? For KNO3, I've got a nitrogen, but it's not attached to carbons, and so this isn't an organic nitrogen. So I wouldn't classify it as a base. It has no hydroxides. There's no H in front. No evidence of carboxylic acids. So this is just a salt. Right? FeOH3, now I have an ionic compound, but we actually have hydroxide ions as the anion, and so that's going to produce hydroxide ions when it dissolves in water, so that will be a base. I have another compound with the H in front, so this would be an acid. We have another ionic compound with hydroxides, so this would be a base. I have now NH4Cl. So this is a little bit tricky. So I've got that nitrogen, and it doesn't look totally dissimilar from ammonia, but if we consider the Lewis structure for the ammonium ion, but essentially this is an ammonia that has already accepted the proton, and so we would not classify this as a base. Now, as we'll talk about later on, this ion is in fact weakly acidic, but we would classify this as a salt. And then in my last two examples, so now here's an organic compound, and we've got the nitrogen. It doesn't have a positive charge like ammonium, and so this is very similar to ammonia, so we would classify that as a base. And then in this last compound, we have this carboxylic acid group, so we would recognize that as an acid. Now, I didn't talk about whether these were strong or weak bases, so let's go back and do that. So sulfuric, and the way we know that is because we've learned the 7 strong acids and the 8 strong bases. Sulfuric acid is one of the 7 strong acids that we've learned, so that is a strong acid. FeOH3 is not on the list of strong bases, so that's weak. HClO, not on our list of strong acids, so that's a weak acid. The 8 strong bases are the alkali metal hydroxides, and then in the alkaline earth metals, when they form hydroxides, calcium, strontium, and barium hydroxides are strong bases, so that would be a strong base. And then these organic acids and bases, they are weak. They are not strong, so both of these would be weak.